Welcome to Part 5 of the series, Control Mapping and the Statement of Applicability. This is the point where risk, controls, and audit come together, and where governance becomes an operational reality. Up to this point, we have defined the organization's context, aligned the management system through the clauses, and established how risk is identified and assessed. Now, we move into how those risks are treated. This is where controls are selected based on risk, implemented across the organization, and formally documented in the Statement of Applicability. It is also where traceability is established, linking risk to controls and controls to implementation and evidence. This is what allows the management system to move beyond documentation and become something that is measurable, auditable, and effective in practice. To bring everything together, we can view this as a continuous life cycle. It starts with risk. Risks are identified and assessed across security, privacy, and artificial intelligence, using a structured approach to understand cause, event, and impact. From there, we move into treatment. Decisions are made on how to address the risk, whether to mitigate, avoid, transfer, or accept it. Where risks are treated, controls are required. These controls are selected based on the risk and sourced from standards such as ISO 27001, ISO 27701, and ISO 42001, as well as other relevant frameworks where needed. These decisions are then captured in the Statement of Applicability. The SOA records which controls are selected. A control is something you implement to reduce risk. It's the actual safeguard, whether that's a policy, a technical solution, or a process. The Statement of Applicability, on the other hand, is not a control. It's a document that explains which controls you have chosen, why you've chosen them, and whether they've been implemented. So controls are what you do, and the SOA is how you justify those decisions, especially during an audit. This slide shows a practical example of a control in operation, bringing Clause 8 to life. We are looking at Control A.5.17, which relates to authentication information. The control is multi-factor authentication for remote access, with the objective of preventing unauthorized access to systems and sensitive data. The control description defines how the control operates, requiring users to authenticate using both a password and a second factor, such as a mobile application or hardware token. Implementation is enforced through an identity provider and applies across VPN access, cloud applications, and administrative accounts, with conditional access rules in place for higher-risk scenarios. From an audit perspective, evidence is critical. This includes configuration screenshots, access control policies, user access logs, conditional access rules, and audit logs demonstrating that multi-factor authentication is enforced. This represents the control in operation, not just documented, but implemented and evidenced. Control effectiveness is then assessed under Clause 9, based on monitoring, testing, and review activities, and should include a defined review date. Finally, we classify the control. In terms of function, this control is primarily preventive and deterrent, although it may also support detection through logging. In terms of type, it is a technical control, supported by administrative elements such as policies and procedures. This example demonstrates how a single control moves from design to implementation to evidence and ultimately to effectiveness, forming a key part of an auditable and operational management system. Controls can be understood by both their type and their function, but in an integrated management system, they must also be understood across multiple standards. The type of a control describes what it is, whether technical, administrative, or physical. The function describes what it does, whether it prevents, detects, or corrects a risk. What's important is that a single control can support multiple domains. For example, multi-factor authentication supports security under ISO 27001, privacy under ISO 27701, and artificial intelligence under ISO 42001. Similarly, controls such as data minimization, AI model validation, and supplier management extend across privacy and artificial intelligence domains. This demonstrates that controls should not be implemented separately per standard. They should be unified, aligned to risk, and designed to operate across all applicable domains. Now let's talk about control effectiveness, because having controls in place is not enough. What matters is whether those controls actually work. A control is considered effective when it is appropriately designed to address the risk. It must be implemented correctly, not just documented, but actually in place. It must also operate consistently over time, not just once off or during an audit. And most importantly, it must reduce either the likelihood or the impact of the risk. This is where many organizations fall short. Controls exist, but they are not truly effective. Control effectiveness also directly influences residual risk. If a control is weak or not operating as intended, the residual risk remains high. But if controls are strong and consistently applied, the organization's risk exposure is reduced. This is what organizations need to demonstrate, not just that controls exist, but that they are working, measurable, and reliable. At its core, the SOA is a list of selected controls, but it's much more than just a list. It records exactly what controls are included and excluded, and importantly, provides the justification for those decisions. This is critical, because controls should never be selected randomly, they must be driven by risk. The SOA also creates a direct link between risk and implementation. It shows how identified risks are being treated through specific controls, and this is exactly what auditors will look for. Now, in an integrated management system, this becomes even more powerful. Controls may come from different standards: ISO 27001 for security, ISO 27701 for privacy, and ISO 42001 for artificial intelligence. But they are not managed separately. They are brought together into one unified statement of applicability. This means one control environment, one source of truth, and complete traceability across all domains. This slide shows how that same control is represented in the Statement of Applicability. The Statement of Applicability is not the control itself, it is the documented justification of control selection. In this example, we can see the control reference aligned to ISO 27001, Annex A, Controller Point 5.17, which relates to authentication information. The control is marked as applicable, meaning it has been selected based on the organization's risk assessment. The justification for inclusion explains why this control is necessary. In this case, to mitigate the risk of unauthorized access to systems and customer data, particularly in a cloud-based and remote access environment. The implementation status confirms that the control has been implemented, and the description provides a high-level summary of how, specifically, that multi-factor authentication is enforced for remote and privileged access through an identity provider. Importantly, the control is linked back to a specific risk, R-001, ensuring full traceability between risk, control, and treatment. We also see mapping to additional standards, including ISO 27701 for privacy and ISO 42001 for AI, demonstrating how a single control can support multiple domains. And finally, where controls are not excluded, the exclusion justification is marked as not applicable. So while the control operates in the environment, the Statement of Applicability provides the formal record, explaining what has been selected, why it has been selected, and how it is implemented. Now that we understand what control effectiveness is, the next question is, how do we actually assess it? Control effectiveness is not based on assumption. It must be measured, observed, and verified. It starts with monitoring and metrics. This includes system logs, alerts, anomaly detection, and the tracking of key performance and key risk indicators, giving real-time visibility into how controls are operating. Next, we have reviews. This includes access reviews, management reviews, and process reviews, ensuring that controls remain appropriate and aligned to the organization. Then comes testing. Controls must be actively tested, whether manually or through automation. This includes activities like penetration testing, as well as validation and testing of AI models where applicable. And finally, assurance activities. This is where independent validation takes place, through internal audits, external audits, and compliance checks. Together, these activities provide a complete view of whether controls are not only implemented, but operating effectively and consistently. In addition to defining what is measured, it is equally important to define how it is measured, how often it is reviewed, and who is responsible. Measurement is performed through system logs, identity provider reports, access reviews, and audit evidence. Monitoring takes place continuously, with formal reporting performed monthly, and detailed reviews conducted on a quarterly basis. Ownership is clearly assigned, in this case, to the IT security manager or identity and access management lead, ensuring accountability and consistent oversight. This level of definition is critical, because without clear ownership, frequency, and measurement methods, control effectiveness cannot be reliably demonstrated in an audit. Now let's look at what good control mapping actually looks like in practice. It starts with traceability. Every control must be linked back to a defined risk, following a clear path from risk, to treatment, to control, and ultimately into the statement of applicability. There should be no orphan controls. If there is no risk, there is no justification for the control. Next is evidence. It's not enough to say a control exists, you must be able to prove it. Evidence should clearly demonstrate that the control is implemented and operating. This can include logs, reports, dashboards, review records, and audit results. Because in an audit, if it's not evidenced, it doesn't exist. Then we look at consistency. Controls should be selected per risk and applied across standards, where applicable. Where the controls align, an aligned definition, and a single, aligned treatment approach. This creates one control environment that supports multiple standards. And finally, effectiveness. Controls must be tested, monitored, and reviewed. They must be assessed and rated, whether effective, partially effective, or ineffective, and directly linked to residual risk. Because ultimately, controls must not only exist, they must be proven to work. And when done properly, control mapping creates traceability, consistency, and true audit readiness. This slide shows how control overlap occurs across security domains when integrating ISO 27001, ISO 27701, and ISO 42001. What we see first are the core security domains, such as governance and risk, identity and access management, data protection, monitoring, incident management, supplier management, human awareness, compliance, and lifecycle management. Across these domains, there is a very high level of overlap. While the controls may differ in wording, the underlying intent is consistent. For example, access control exists in all three standards, applied to systems in security, personal data in privacy, and models and platforms in artificial intelligence. Similarly, monitoring, incident management, and supplier controls extend across all domains, each adapted to the specific risks of security, privacy, or AI. This is where integration becomes practical. Instead of implementing separate controls per standard, organizations can design a single control environment that addresses multiple requirements simultaneously. The slide also highlights areas of partial overlap. Privacy-specific domains, such as data subject rights and purpose limitation, are core to ISO 27701, but only partially addressed in the other standards. Likewise, AI-specific domains, such as ethics, bias, and explainability, are central to ISO 42001, with limited coverage in security and privacy. This reinforces an important point. Integration is not about making everything the same. It is about aligning shared domains, while recognizing and managing what remains specialized. Ultimately, the strongest approach is to design controls once, align them to risk, and extend them across domains where applicable. This slide brings together the Annex sources across security, privacy, and AI, showing how the control domains align across the three standards. Starting with ISO 27001, we see the core security domains covering governance, access control, infrastructure, application security, monitoring, resilience, suppliers, and people. ISO 27701 builds on this by extending into privacy-specific domains such as PII processing, data subject rights, data minimization, cross-border transfers, and privacy by design. ISO 42001 introduces AI-focused domains, including AI governance, lifecycle management, model development and validation, bias and ethics, transparency, and human oversight. Together, these annexes demonstrate how security, privacy, and AI are not separate, but interconnected domains that can be managed through an integrated control framework. Now let's look at what you can expect in an audit. Auditors are not just checking documentation, they are looking for clear, consistent evidence that your management system is working end-to-end. It starts with risk management. They will expect to see that risks are clearly defined using a cause, event, and impact structure, assessed consistently, and linked back to your business context under Clause 4, as well as treatment decisions under Clause 6. Next is control selection, captured in the Statement of Applicability. Auditors will look at whether controls are selected based on risk, properly justified, and not randomly included. Then we move to control implementation under Clause 8. Controls must not only exist, they must be implemented and operational, and aligned across security, privacy, and artificial intelligence. Evidence is critical. Auditors will look for logs, reports, records, and review outputs that demonstrate that controls are actually in place and functioning. Then comes control effectiveness under Clause 9. Controls must be monitored, tested, and reviewed. Effectiveness must be measured and documented, not assumed. And finally, improvement under Clause 10. Auditors will expect to see that issues lead to corrective actions and improvements, and that there is clear evidence of continuous improvement across the system. This is what an audit really looks for, not isolated controls, but a connected system that links risk, controls, evidence, and improvement. In Part 5, we brought everything together into a unified control framework. We mapped risks across security, privacy, and AI to controls, and aligned them to the Statement of Applicability, creating a single, structured view of governance. But integration does not mean that everything is done in exactly the same way. While the framework is unified, the way controls are applied, and the way risks are managed, can still differ across domains. And this is where many organizations get it wrong. In the next part, we'll explore what must still be done separately, and why that distinction is essential for building a truly effective and audit-ready integrated management system.